डियर स्टूडेंट, सब्सक्राइब बटन और बेल बटन को दबाएं ताकि मेरे वीडियोस आपको सबसे पहले मिल सकें।
Alright, my dear students, let's have the concept of equal vectors. I have considered some example here. Vector AB 5 minus 4, vector CD minus 5 4, vector PQ it's a minus 5 and minus 4, and vector RS is 4 and 5, and vector UV 5 minus 4. If you look on these examples, the magnitude of all these vectors is same. If we operate the formula of magnitude on all these given vectors, you will see you will get the same answer. It means the length portion of all these vectors is same. This portion, this length portion is same, but this is not same. The direction is not same. An equal vector concept is that two vectors will be equal if number one, their length must be same, number two, their direction must be same. Then we say that the vectors are equal. And when we are in column vectors, we can have more help from the components, that's along x-axis and y-axis. But you see, if I've discussed with all these vectors that they have magnitude, same magnitude, but the directions are different. So column vector can easily be understood because their component along x-axis, y-axis, and their sign help us whether they are equal or not. So clearly, we can easily say that yes, these two vectors are not equal because the direction of y is negative here, and here we have 5, here we have minus 4. So they are totally different. The conclusion is, in column vector, equal vectors are those vectors whose respective components are same. जिनके respective component आपस में बराबर होंगे वो equal vector कहलाएंगे. If we look at all these, check this vector AB, and if we move this vector from this to this UV, you can see the x component is 5, here x component is 5. So y component is minus 4, y component minus 4. So only vector AB is equal to vector UV. There not only the length is same, their magnitude is same, but definitely their direction is same. But x component along x component is same, and y component along y component is same. That's why these two vectors are equal vector. This is the concept of equal vectors. In general, I have told you two vectors will be equal if their magnitude, that is called length, and direction are equal. We say that the vectors are equal. And in column vectors, if the respective components of the vectors are equal, then the vectors will be equal vectors. Now let's have what is the use in problems of this concept of equal vectors. For this, we will consider one example that will help us to solve its application sort of question, that how can we find some unknown given in equal vectors. Alright, my dear students, let's have one example to understand the use of concept of equal vectors. In this statement, we have given two vectors, vector A with these components m plus 4 and 12, and vector B with components 10 and 4 minus n. And condition is given that if A is equal to B, then we are supposed to find the value of m and n involved in both vectors. Here is the process of solution. My dear students, we will use this given condition in the question that the both vectors are equal. It is given that this vector is equal to this vector. We will write their vectors here. Vector A is m plus 4, and vector B is, this is 12, and vector B is 10, and this is 4 minus n. Why we have taken like this? Because it is given that both vectors are equal, and when this equal sign is there between the vectors, mean equal, it's mean according to the concept their respective components are definitely equal. So implies that what will we do? We put this component, x component, equal to this x component, and we'll solve it to get the value of unknown. It's m plus 4, this is equal to 10, this is equal to 10, and implies that this m will be equal to 10 minus 4, and finally m has the value 6. Similarly, this y component will be equal to y component, and this 12 equals 4 minus n. Now we will work for finding n. Let's transfer this n towards this side, will become positive, and 12 will move towards right side like this. This is n is equal to, this is 4 minus 12, my dear students. And now let's subtract them. We will get the value of n. N is equal to minus 8. So therefore, after using the condition of equal vectors, we got m is equal to 6 and n is equal to minus 8, my dear student. This is the use of the concept of equal vectors. And it's so easy. If you do it 1 or 2 or 3 times, you won't waste it from your mind whenever you need it to utilize the concept of equal vectors. Just get 1 or 2 or 3 questions practice, that's enough to maintain your concept of using the concept of equal vectors. Alright, my dear students, let's have the topic addition and subtraction of vectors with scalar multiplication. We will learn addition process along the column vectors, subtraction, and the concept of scalar multiple with the column vector. Let's have an example. This is example here. Part A, evaluate. So 5 minus 12 plus, this is 8 minus 2, and part B is evaluate 11 minus 2 minus, this is 10 and 5. We have given 2 examples. I'm just giving a basic idea. Actually, this is already done in the concept, in the topic of matrices, but a little concept, and then we will carry on this process. In this part A, it is mentioned here, you just add up these 2 column vectors, and here you need to subtract them. Here is the solution process. Let's write part A, and this part is 5 minus 12, and then this is 8 and minus 2. The addition and subtraction concept is 100% same as we have done in matrices. And what is that? Deal the respective members. The x component, the first component with the first one, the y component, the second component with the second component, in the same way as we deal in arithmetic numbers. We deal with the numbers according to their signs, and we add or subtract. If they finally, after using this sign, if they will have same sign, we will add them. If they will have opposite sign, we will subtract. You'll see here, this is 5, positive 5 and positive 8 will give us, it's 5 plus 8 and minus 12 minus 2, minus 12 minus 2, and finally this is 13, this is minus 14. You can directly add them and write this answer. You can write this answer directly, this one. This is just a process to show you what happened actually, but to just add them, write this directly, add them because they have same sign negative, write it here with their common sign. And in part B, if we see, we have given two column vectors and we are supposed to subtract them. Let's subtract them. This is 11 minus 2, and let's subtract this vector 10 and 5. As I told you that we need to deal the respective members, this 10 will be subtracted from 11 and the answer would be now here 1. And here is minus 2, and after utilizing this minus it will become minus 5. Minus 2 and minus 5 having the same sign, so they will become minus 7. This is a concept in column vectors, how we are supposed to add them and subtract them. Let's have some upgraded, one step ahead, up level example for addition and. Alright my dear students, let's have example number 2. We have given 3 column vectors A, B and C, and we are supposed to evaluate these expressions. Here we have A plus B minus C, composition, addition and subtraction, and here we have scalar multiple. I'm including this concept now here, how we will multiply any number outside the vector, and then again addition and subtraction in the same way. Let's solve this example and learn how to handle this kind of expression when their column vectors are given. For part number A, I will write the expression as it is. This is A plus B plus C, and now I will substitute their column vectors A, B and C here in place of them, and then carry on, this is minus, carry on these operations. Here is column vector A with components 3 and 7 plus this is I will write the column vectors here in place of these A, B, C. Alright my dear students, let's write column vectors here and simplify them according to the operation mentioned here. We will substitute A vector here. This is 3 and 7 plus vector B is 4 and 1 minus vector C is 5 and 1. Well, you can directly deal all three directly, or you can first add up these two and then subtract the 5 1. It's totally up to you. There is no need to be a specific for a particular sense. As first add these two numbers, 4 plus 3, that will become 7. And when we subtract this 5, we will get 2 here. And 7 plus 1 become 8. And we subtract 1 from it, we'll get 7. This is direct addition and subtraction of this expression, and we have got the answer 2 and 7 here. Let's see part number B. Here is part B. We will write as it is given here, and this is 2A minus B plus 4C. We will write respective vectors here and then carry on its simplification. This is 2 and the column vector is 3, 7, vector A minus B. This vector is 4 and 1 and plus 4, 4C, and C vector is 5 and 1. What is the concept of scalar multiple? Whenever there is a multiple, like we have in matrices, if there is any number outside any matrix, we need to multiply this inside the column vector with both members. Outside number will multiply with the both members like 3 and 7, दोनों के साथ बारी बारी ये multiply होगा. Similarly ये 4 दोनों components 5 and 1 के साथ 1 by 1 multiply होगा, and then we can in the same way add and subtract. Alright, let's see here. This step become, when 2 multiply with 3 will become 6, and when we multiply 2 with 7, this will become 14. This is 6 and 14. This is the first step here, first column vector. The second one is remains same, and the third one plus, when 4 multiply with this one, this will become 4 times 5 20, and 4 times 1 is it will become 4. Now this question becomes like we have already done this question here. This is some column vectors are in addition form, some is in subtraction. We can do this directly, no problem. Subtracting 4 from 6, we will get 2 here. This positive 2 when added 20, we will get 22. And when subtracting 1 from 14, we will get 13. And this 13 is added in 4, we got 17. Here is the answer, my dear students. After scalar multiplication of the numbers with the column vectors, and then reverting back to the process of addition and subtraction. So according to the given sign, we have evaluated the answer for this expression that was given in the example. So this is the concept in expression form. Yes, addition and subtraction is also involving an equation as well. We will see in the next coming up example that how addition and subtraction and scalar multiplication is actually behave in the form of equation. We'll see in coming up example. And I hope you have learned it. It's too easy. The concept is 100% similar as you have done it. My dear students, let's have example number 3. This is related to the equation concept involved in column vectors. Here we have given an equation in which you can see that we have 2 unknown given, and we are supposed to find them. Well, there is scalar multiple is there, and then subtraction concept is looking. There are 2 ways of simplification. You can multiply 2 here and directly write expression equal to this component and then solve it. And similarly multiply this 2 with 5, it will become 10 minus 3y, that can be equated to minus 10. But the concept that is actually working behind is the concept of equal vectors. The better is, let's simplify the left hand side in the form of single matrix, and then both side matrix will be equal. Then we will equate their respective components, as we have learned the concept in equal vectors, because this sign will equate them. Let's simplify this side first. Let's write it. This is a question we have given. This is 2x5 minus, this is y minus 3, and this is 3y, and this is equal to 4 minus 10, my dear students. We will work on this side first. Let's multiply 2 with this number, become 4x, and minus this term. This is 4x minus, because this is negative sign, this will become minus, this will become positive, minus y plus 3. And then we multiply 2 with 5, become 10, and we will write with it, this is 10 minus 3y. What we did, we simplified left hand side both terms according to the concept we learned, addition subtraction, and that is equal to 4 minus 10. Now look, we did question where on either side of equal there were one column vector, and we utilized the concept of equal vector, and that was the x component. The first component is definitely equal to the first one because this equal says it is only possible when respective components are equal. So we will equate this with this one and this with this component. Let's write it. This is 4x minus y plus 3. This is equal to 4. And the second one is we have 10 minus 3y is equal to minus 10. To get the value of y, we transfer this 10 to this side and we take y on other side. And this will be 10 plus 10 is equal to 3y, and this is 20 is equal to 3y, and y will be equal to 20 over 3. Now we want to find x, and in this equation you can see we have two unknowns. So we bring this value of y that we have found here, we will substitute here to get the value of x. Let's modify a little this step. This is 4x is equal to 4 minus 3 plus y, and this will give us 4x is equal to 1 plus y. Now we will substitute this value of y here and we can check it here. This is 4x is equal to 1 plus y, that is 20 over 3. Let's simplify. This is 1 here denominator. It's an LCM process as you work while taking LCM or equalizing the denominators first, like 1 plus 20 over 3. This one can be multiplied by 3 to make the denominators equal, and we have to multiply this numerator as well. This will be 3 plus 20, and here it would be 3. And here we have 4x. And now finally this is multiple here, we'll divide on the other side. X will be equal to 20 plus 3, this is 23, and this is multiplying here. When we transfer to the other side, we'll divide on the other side. This is 3 multiplied by 4, and this x will be equal to 23 by 12. Well, both answers where y is equal to 20 over 3 can be written in mixed numbers, that x is equal to is one whole number 11 by 12, and y would be, if we divide this by this, and this is situation question only 1 remaining 11. Similarly, if we divide 20 by 3, this is 6 whole number 2 by 3. We divide by 6 is 18, and remainder here, and here is quotient, and this is finally, these are the answer values of x and y given in the example. So my dear students, this is the level of use of addition, subtraction and scalar multiplication in the topic of column vectors. These are different stages of this. Its use, you can say its application. So maximum about the addition, subtraction and scalar multiplication in column vectors. And I hope you enjoyed it. This is so simple related to matrices, and if you are good in matrices, you must be very good in this part of vector. You won't be any problem.